Okay. We are live. Stream manager says we're live. I'm getting sound coming back. Very good. All right. Let's do some code. All right. I'm just gonna continue doing what I was doing yesterday, which is just all the popular. Just sort by popularity on the kata practice and do kata I have not trained on. Any difficulty, and yeah, I think that's it. I'm ready to go. Okay. This time, no story, no theory. The examples below show you how to write function accum. All right, examples. Accum of ABCD reduces. I see. So the first letter gets multiplied once, or has a multiplicity of 1. The second letter 2, the third letter 3, fourth letter 4, with the first one being capital. Okay, that's easy. Okay, input string. Let's do string or output strings. I'm gonna make that just an empty list. I'm gonna be iterating over the character in the input string. So for CNS, I'm actually gonna take advantage of this function called enumerate, which turns iterating over a single iterable where it would normally return a single item. Wrapping it around enumerate, it's going to return a tuple of items. The first element being the ith element in the original iterator or iterable, and then the second element being what you would normally get from that iterable. And then I'm going to do so let's do a new string equals. It's always going to be the first, or the first letter is always going to be the capital of the input letter. So let's do C dot upper. Oh, well, then new string plus equals the string times. So for those who don't know, multiplication of strings between, or multiplication between strings and integers return a string where the string is multiplied n times. So in this case, c times I would be the for like example ABCD, right? First time through this, C is A, and then it would be multiplied 1 time, and then the next time through would be B, it'd be multiplied by 2. Except that we're already accounting for one of the instances of that letter, specifically the uppercase instance here. So really this should be I minus 1. And at the end of the for loop, we're going to append it. So output string dot append new string. And finally, once we've done all the iterations that we're going to do, you're going to return a join on the hyphen, and then output strings is what you're joining together, and that should do it. Okay. Well, I messed something up. Okay. So I actually starts at 0. So really this should have been I plus 1, but since we're doing a minus 1 anyway, I actually should just be able to leave it as I. Except that didn't work. Did I just misunderstand the prompt? Oh, I see. It's even if the input is a capital letter, only the first one should be capitalized, which I am not adhering to, right? Yeah, see, this is all capital U's. So this should always be C dot lower, and that should do it. Boom. All right, what's going on the stream? No one is watching me, except for 2 viewers, which are probably just like bots or something. Okay, on to the next one. Get the middle character. You're going to be given a word. Your job is to return the middle character of the word. If the word's length is odd, return the middle character. If the word's length is even, return the middle 2 characters. Okay. That's doable. Main. So if length of s mod 2, this would be inside this conditional. If it is odd, then we're just returning the middle character. So that's gonna be do I need to do logic? So what I can do is I can do length s. Oh, I hate that. Yeah. All right, length of s, and then I equals len over 2. But is it easy to see if something's a fraction? I think checking ahead of time to see if it's even or odd, and then having my division logic depend on that case is fine. So if, so I don't have to call it twice. Len equals len of s. if len mod 2, this will be even, or sorry, this will be odd. So then it's just a matter of returning s of length of divided by 2. Ooh, ooh. That is gonna, but I want to do integer division. Oh. Okay, we'll see what that. Sometimes when I'm coding, it's good to always think through the problem, but sometimes it's also better to just try your idea and see what it's doing instead of what you actually want it to do, and then it's more of a obvious delta. Okay, I know what it is doing. Here's how I get it what to do. Otherwise, until you run it, you don't know for certain what your current code is doing. Um, maybe I'm just dumb, but that's sort of my approach to things. And then if not, then I'm gonna do return s of, let's do index, or just I equals length 2. This should be a float. Yeah, what's up? I'm streaming. What? I do not care about cats. What? What is that? I don't want that. Okay. I don't want them on stream with me. Oh, the problem statement is that. Sorry. Oh my gosh. Fine, the streamers want to see the cat. Fuck me, who's probably allergic. Cat is apparently afraid to come upstairs and started crying immediately. So we're not doing that again. Okay. Problem statement is get the stuff in the middle. I to I plus 1, except I might have to shift it. We'll see. We'll see what this returns. Okay, so it is s should equal. Oh, okay, so I've just gone the wrong way. So I need to do, if I just do I minus 1 here, that should do it. Cool. Okay, that's pretty straightforward. All right. Trying to like go through as much as possible, but I instead of back. No, don't. Oh, poor baby. I mean, it is one of the cuter cats, but I don't. Not a cat person, obviously. Definitely more of a dog person. I like some cats, but in general, it's not even that I don't like cats. I don't like cats that are pseudo pets when I have a roommate agreement that says we shouldn't have pets. And we're just allowed to bring in these strays all the time, but I'm not allowed to have my dogs. Um, you're a square. Why, thank you. A square of squares. Why, yes. How did you know my name? You like building blocks. You especially like building blocks that are squares. Yes. And what you like even more is to arrange them into a square of square building blocks. Okay. However, sometimes you can't rearrange them into a square. Instead, you end up with an ordinary rectangle. I hate when that happens. Those blasted, non-perfect squares. If you just had a way to know whether you're currently working in vain. Wait, that's it. You just have to check if your number of building blocks is a perfect square. Okay, so the fun part of the problem, they just like spoil it for you. I don't know. I think that should have just been a you figure it out. Um, determine in mathematics a square number or perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. The test will always use some integral numbers. So don't worry about that in dynamic type languages. Okay. Oh, it's saying it's always going to pass in an integer. Okay. So, I mean, is it, I'm trying to think about how to, I mean, is it really just return? Okay, well, so I could take the square root and see if if it returns a valid integer. Python, line, just so I can test something out. Python anywhere, blah, blah, blah. Okay, so, like, let's say it's not a square. Okay, so that's just gonna return. So I could see if int of number to the 1/2 equals that value, right? So if I have num equal 9, for example, and I do 9 to the 1/2, I'm sorry, what? Oh, and then I can, does that exactly equal? I don't think it does, because floating, not necessarily, right? Because not every floating point number is exactly that number. This doesn't exact necessarily, and it does in this case, but I feel like it wouldn't be hard to find, right? Oh, well, no, so 4. Interesting. Maybe if it's an integer, no, yeah, see that does a float. I know for a fact that that wouldn't work. You can't take the square root of any, right? Not all integers have an exact floating point representation, and then the equality check, I believe, is going to care about that. I mean, I could brute force this where I just start with 1 and work my way up until it is greater than, right? And just keep squaring it. It's what's on my mind, so I'll try it. So while I squared is, well, how does I Squaring an integer. That should... Hold on. Do always... Uh, um... Okay, I'm gonna try what I'm thinking, and I'll be surprised if it works. So so uh, root equals n 1/2 if root equals int of root, then return true. It was a valid square number. Else, or and then just return false. Ah, a string, a bytes-like object or real number, not complex. Oh, what are negative values? Okay, well, so this is obviously susceptible to regular or negative integers. So if n is less than 0, return false. Okay, that passed. I guess that surprises me. Because integer is going to return an exact integer. But maybe the way Python handles typing isn't the same as, like, if I have to worry about an integer type versus a floating point type. They might all just be the same thing. That's actually something I don't know. Anyway, I'm gonna move on because it worked. Num to the power of 0.5 mod 1 equals 0. Um, mod 1. Oh, sure. Right, yeah, check if 1 goes into it. Yeah, that's fair. I still would be interested to learn about the different types at play there. Anyway. Oh, back, you fool. Sum of positive. Oh man, we're close to 1337. Ooh, should I bookmark it so that it is? Yeah, I was the elitist bookmark. Cool. All right, let's train. Get an array of numbers. Return the sum of all the positive ones. If there's nothing to sum, the sum is default to 0. Okay, well this is pretty easy. Oh, yeah, this is an 8Q. This is like as easy as it gets. So item in R if item is greater than 0. Item for item R. I just messed up the syntax. I also didn't return anything, so that's nice. There we go. Okay, easy peasy. Find the parity outlier. You're given an array which will have a length of at least 3 but could be very large, containing integers. The array is either entirely comprised of odd integers or entirely comprised of even integers, except for a single integer n. Write a method that takes the array as an argument and returns the outlier. Okay, so hold on. Except for a single integer. So write a method that takes an array. Okay, so okay, I need to determine if it's supposed to be an even one or an odd one, and then find the even or odd one. So I'm actually going to make myself a helper function. So def is even integer. Return integer mod 2, not that. So return not integer mod 2. I actually want to test that. So is even of integers first one. Oh, true should equal. Sorry. Well, print integers. Print. See if that's working. Yes. Okay. So then for integer and integers, always at least 3. There's definitely a couple of ways you can solve this. Dude, I am struggling today. I could do I guess I could check the first 3. That would always I could always determine. But that doesn't sound right. Out of PP, yes. Oh. Hmm. While okay, let's do parity equal. One or same parity while same integer equals. I'm gonna be a little verbose with this just because I'm needing to think my thoughts out. Integer equals integers of 0 Except now I need, so actually, so I want, sorry, of I by 1, last integer equals integer. And then we're starting at 1. So last integer, or we'll do last pair is even. So true will be even, parity, false will be odd parity. Then I'm gonna current parity. Current if current parity last parity rather not then integer. Well, same. Wow. So I get in here at least once. Oh, well, actually, I would say break else. Integer of what I need to do is reset though. So last parity equal. Dude, now this is not the strat. I am struggling. Okay. You're given an array in which will have a length of at least 3 but could be very large, containing integers. Integer array is either entirely comprised of odd integers or entirely comprised of even integers except for the odd integer. Write a method that takes the array as an argument and returns the outlier. So what I want to do is just start iterating over it and compare to like the previous one and see if it's changed. And if it has changed, then that's potentially my parity. But then I would need to check the next one to see if it also changes, right? For that to for sure be my parity, right? So I enter it. Compare these two, compare these two, compare these two, compare these two, compare these two. And then that's a potential one, but I still need to compare these two. And then if those are different, then break and return that guy. Okay, so actually, potentially how I want to do this is I'm going to create something called Parity changes. That's just going to be the number of parity changes I come across. Then if that exceeds 1, then I've found my parity. Oh, but how does that? No, that's not going to work. Because what if the parity is at the end? Dude. Check if they're even, and then build an array of zeros and ones. 1 if even, 0 if odd, and then take the sum, and if greater than 1, print the number at which the index, at the index where the 0 is, and vice versa. I think that would work. But that makes it become, well, so let me think. Okay, here, 1, sum, yeah, I guess, and I mean, this doesn't really matter. I guess I'm just thinking in terms of optimization. And it's possible that optimization is going to matter because of the way they've worded it. Because they say it could be very large. Because with that way, with your method, I'd have to iterate over the entire list multiple times, right? The sum is doing an iteration of it. My check on is even is doing an iteration over it. And then to find where the index, where the 0 is, that's another having to iterate through it. Whereas I'm pretty sure this could just be you iterate until you find it, as long as you... Oh, am I overthinking it, potentially? Okay, so what I could do... I'm just going to do a while true and then break when it's time to break. It's potentially not the best way to do it, but that's kind of how I like to think about it. So I equals 0. I so we'll just do A equals integers of I, B equals integers of I plus 1, C equals integers of I plus 2. And I'm actually going to do while I is greater or less than length of integers minus okay, well, so let me think. If it's 3, I want to be able to go, so the minimum case is there's only 3, and then I equals 0. I'll get all 3 of them. I want to quit after that. So length is 3, I starts at 0. I want to do while I equals 1 would break if the length of 3, right? So I want to be able to do I length of integers minus, I need to just type this out really quick. So for example, let's say we have 2, 3, and 4. Length is 3, I equals 0. I basically would break out of the loop when I goes to 1, and in which case I would be length of integers, which is 3 minus 2. So while it's less than that. Okay, I think that's what I want. Might just keep that up there as an example for me to reference. Okay, so now I do if now I think I can potentially apply the logic that you were talking about. Because the odd one out can be the first value. Sure, but I think I can handle that. So if I do parities equals parities nuts. Got him. Okay. Is even of A is even of B is even of C. And then yeah, I can see if I can check what the total parity is from. In theory, I just need to check what the overall. So I need to check if they're not the same, and then find the one that isn't the same. Right? So shit, how do I do that? One, then something's up, right? Because then they're not the same parity. I just need to find which one is different from the other two. So how can I do that? If length of just before I forget, I plus equals 1. Set a pair. I mean, I could just pair. What if I iterate over each of these? Parity. I could come up with the total parity. Well, okay, so I like having that check for the set of it. Hear me out again. Check if the numbers are even or odd. Have a counter for every even number, add 1 for every odd number, subtract 1, then do a check on the counter to see when it switches by checking the second most recent number, the newest counter value. But with a counter, so you're saying even number add 1, and then odd number subtract 1. So let's say we have the case where everything is even, like this, right? So let's do 4, 6, 22, 9, 24, or whatever. So you're saying count over it. So 1, 2, 3, and then subtract 1 and see if it changes. I guess I'm not seeing why I would use a counter here. Right, but I can keep track of when it switches without having a counter. If length of the set is greater than 1, then the parity number is in here. Then I just have to figure out which one that is. How can I figure out which one it is quickly, though? I really could. So let's actually do is even on all of these. That should make less verbose later on. When I'm done with this, I'm gonna look up what the like other people's solutions are, and I'm gonna feel so dumb. I just know it. But it'll be interesting because I should be able to understand what they're doing and then see. And maybe they do have a counter. I'm just not seeing how a counter would help me. It's also difficult to discuss such ideas over Twitch chat. It'd be cool if you could like do this, but with like multiple people, and you could just like go back and forth and see, uh, or yeah, just type on the same sort of scratch paper, and so you can type out your ideas in code. This like this in here. Okay, so if well, okay. Hold on. A parity A B parity B C parity equals C. Here. Okay. So if a parity, maybe I'm overcomplicating things by trying to do it like fancy or whatever, but I mean, I could just write out the actual conditions that I need. So if a parity doesn't equal B parity and doesn't equal C parity, put these in parentheses, and I have to actually do this. Turn A, and then just do the opposite for, oh, well, seem to be on to something at least, because I got 2 of the 3. It's kind of weird that this only has like 3 test cases. So this one I should be parity not equal to A parity, or B parity not equal to C parity. Return B. And then C parity not equal to A parity, and C parity not equal to B parity, return C. And then this might not need this sort of, I mean, it's nice to have as just a protection, but according to the assumptions, I should be able to assume that there will always be a parity, so I should always get into here. So let's test it. Ooh. Oh, no, I've made a terrible mistake. Ah! Stop this madness. Timed out. So I'm hoping it's not because it's taking too long. Actually need but it's probably just taking too long. Oh no, that worked. Oh yeah, cause yeah, that was it. Okay, well I feel kind of dumb. I can befriend users on, oh geez, don't tell me I've been at this for 54 minutes. My goodness. Really? Um, I'll have to look into that. Do you know if we can like code together? I'll befriend you though. What's drop your Codewars name in the chat and I'll befriend you guys. Okay, I've got to see what some of the actual other solutions are because this is only a 6Q. I've done other 6Qs. I've struggled less with like 3Qs and 2Qs. So I'd be curious to know what the other solutions are. Unlock solutions. Well, I've already. Oh, have I not been? getting credit for these because I didn't click. Oh my gosh, I've been clicking test instead of attempt this whole time. So I don't know if I've been getting credit. Oh, that's wild. But, and then it does more, okay, so test does a subset and then submit does all of them. Okay, well, submit then. Well, I've been doing all of these and not getting credit for them, so that's nice. I only did a few today. Yesterday I did like 7. They save if you don't submit, so in theory I should be able to go back and just click submit on it. That's so funny. Okay, Ionic Fox, I'm going to add you. Dude, you just have a load. Oh, I just have to load unfinished problems. I read that as you just have a load of unfinished problems. Boy, howdy, don't I know it. Profile solutions, Krispy Kreme. Okay. Oh, profile solutions. Okay, but how do I add you? I'll add you guys later. I'm gonna stick to the stream, but I'm gonna look at these solutions. Okay, so okay, I think my solution is more efficient. So basically, they're doing if odds return odds of 0 if length of odds is less than else return evens of 0. Oh yeah, that would have done it. Oh, man, boy, howdy, was I? Yeah, okay, yeah, you find all of the odd ones in it, find all of the even ones in it, and then do the logic. So, okay, if I only have one odd, that was the one. Return the odds, and then if I only have one even, return the one in the evens. So that definitely should have done that. But I think mine's faster, right? So they had to iterate over it twice, the entire thing twice, right? I only iterate up to the point where the parity exists. So I think mine's faster. Parity equals n mod 2 for n in integers, right? Okay, so it finds the parity of it, the evenness or the oddness of it. And then integers parity dot index of 1 if sum of parity is 1. Okay, so this solution is the one that I think you suggested, Krispy Kreme, right? So you said check if they're even, and then build an array of ones and zeros. If one if even, 0 if odd. So kind of the opposite of what they're doing, right? Theirs is going to return 0 for even because the n mod 2, and 1 for odd. But take the sum, and if greater than 1, print the number at the index. So yeah, no, that's the exact solution that you came up with, except they did the parity definition differently. But again, I'm pretty sure mine's faster because I only have to iterate over it up until one. I only have to iterate over it once, right? Like, am I crazy? My solution only iterated over it once, and then only up until it finds the parity. All of these top solutions, though, parity calculating. So for example, here this line that is O of n, right? Sure. I mean, the problem is O of n no matter what, if we're talking about orders of magnitude, but you can still get decent speed up, right? Because they have to do the iterate over it twice, and then the index is then iterating up until the point of the parity. So I still avoid having to iterate over the entire thing. I only iterate up to where it finds the parity. And dude, I was feeling bad, but assuming I'm not missing something, I think I'm feeling pretty good because my answer is more efficient, at least time complexity. Zactronics games. Every time you finish a problem, you get a histogram for efficiency, size, instruction count, etc. So you want to optimize competitively. Yeah, I do. I do struggle to just Christy might like some of the Zachtronics games. I mean, I did try TIS 100. Yeah. Okay. Uh-huh. TIS 100 was fun. I might get back to that. I was thinking about that the other day, and I had some fun with it. And I'm definitely a better programmer now than I was then. So I'd be interested to see how I do. Um, yeah, no, I'll definitely stream it if I get back into it. I mean, I say if I get back into it, but what am I doing now? I'm programming, so I might as well do it where it's more gamified, I guess. Find the outlier, list even for n in integers. Okay, so len. Okay, so this solution right here by Tanky 1013 is basically the same thing as the first one. They just did it more verbose. This guy, user 1978124, is taking advantage of list comprehensions, and then this nice if else syntax one liner. But it's functionally the same thing as this guy. So I'm feeling pretty good. I was feeling really dumb for struggling on that one, but I came up with a solution that's more efficient than the top solutions on here. Um, okay, all right. Enough of feeling good about myself. On to the next problem. Yeah, that's it's kind of annoying. Like Twitch will have categories for like only games, or hot tubbing, or just chatting, or drawing. There's no like options for like, oh, I'm programming. Like I can't type that in as like what I'm doing. Um yeah, the fact that this game might get me more exposure. Um that being said, I don't know, man. There's a lot of popular coding content out there on YouTube. It would surprise me if streaming code didn't become more popular as well. I mean, I'm not saying that I think it's going to happen with me, but if someone else that's already sort of popular in this space started doing it, I think people would listen into that because people want to listen to higher level programmers, and I'm not saying I'm a higher level like a good programmer necessarily. But I think people would be interested in hearing how people think while they program. Um, all right, isograms. An isogram is a word that has no repeating letters, consecutive or non-consecutive. Implement a function that determines whether a string that contains only letters is an isogram. Interesting. Okay, so ignore letter case. Um, so, hmm, sorry, I kind of zoned out for a second. So, is isogram? Hmm. Oh, this is an easy problem. Okay. This is with Python. This is a very easy problem. So all you got to do is see if, well, first of all, let's do string equals string dot lower, just so that since we're ignoring case, if we all just make it lowercase, the logic will be the same. And then it's just a matter return length of string equals length of set of string, right? Because yeah, if they're all unique letters, then putting it into a set will have the same length as the original string. Okay, so pass the test. Let's attempt it. Okay, now I'm gonna submit it. Okay, that was a nice little break from me from the last one. Yeah, okay, so all the top problems are gonna be top solutions, I guess. This one's interesting. So they actually don't make use of a set. String.lower for letter if string dot count. Oh my god. Oh, that's not efficient at all. Right? Because when you do string dot count, you have to iterate. So they've turned an O of n problem into an O of n squared problem with this dot count, right? So because they're iterating over the string, that's O of n. And then for each item in that, they're doing another iteration with this string dot count. So a lot of people upvoted this as best practices, and I don't think so. I think that if you have an O of n problem, you should not turn that into an O of n squared problem. That's just me. Let's see what else. I think I'm gonna start going over the other solutions afterwards, just to sort of, oh, I didn't think of it like that, and hopefully gain some more knowledge. Um, Same stuff overall, though. It's same idea. Yeah, the condition is, does the length of the set equal the length of the original string, and you have to call dot lower on it. So this was something I thought of for a second until I realized I could just do it with a set. Basically, you can come up with a dictionary where each key is one of the characters in it, and then the value is the number of times that appears. Except you wouldn't even have to do that, right? So yeah, they iterate over it to fill up the dictionary, right? And then they check to see if any value in that dictionary is greater than 1, and then if so, return false. But you wouldn't need to do that. You would just need to check to see if the character was already a key in the dictionary, and then break out of it right then and there. So here they've made it an O of n problem and O of 2n problem, because you essentially have to iterate over it again after you're done filling out the dictionary. But then again, that's sort of when I realized that, okay, if I do the dictionary method while I was thinking about the problem, oh, I wouldn't need to add it and then check for it later. I could just check then and there. I was like, oh, wait a minute, that's just a set, but with extra steps. So, okay. Counting duplicates. Okay, another 6Q. Hopefully I don't struggle with it as much as I did the first one. Let's go to train since it has the problem prompt in there. Write a function that will return the count of distinct insensitive alphabetic characters and numeric digits that occur more than once in the input string. The input can be assumed to contain only alphabets, both uppercase and lowercase, though. Okay, so any string that occurs more than once, it out or detect that, and then sum the total number of strings that occur more than once. But just because one occurs more than twice doesn't mean you count that again. Okay, so this one I might actually do the dictionary one that we came up with. Not the potentially not the fastest method. Oh, but what I could do is I can have two sets. So I can have past characters equals one set, and then repeating characters in another set, and then just return the length of repeating characters. So I can go over well, so it says case insensitive. So I'm just gonna, at the very beginning, do text equals text dot lower, and then for car care in text, if car in past characters, then we're going to add it to the set of repeating characters. Repeating characters, and if I remember correctly, the syntax is dot add for a single element. I think update would be if I had another set that with that would combine the two. Or would it be dot union for sets? Anyway, so dot add the character, right? And then I'll also want to add to past characters the current character, right? And then I can just return length of repeating characters. If I'm understanding the problem right, that is. Let's see. Okay, the test passed. Woo! Okay. That one uh that one I felt pretty good about. So let's submit it and then take a look at the solutions, other solutions. A clan in your profile and we can match it. It's apparently the only way to quickly befriend people you know. Okay, let me try that. Get a new tab. Oh, I might have. Did me and Christy make a clan? It's possible. Do you know how to make a clan? Social, maybe? Not started following. Oh, followers and allies. Oh, but where's a click icon picture? Okay. Oh, like up here? No. I just blind. Count settings. Okay. Ooh. I don't have any personal information in here. Let me turn that off and verify. I'll just add you guys later. I have your guys' usernames, right? Christy Cream 307 and Ionic Fox. So I'll definitely add you guys. Okay. Oh wait, no, I wanted to take a look at the solutions. duplicate count length of C for C in set S. See, yeah, this dot count, it'll get you because it's not an O of 1 lookup. It's an O of n lookup, if I remember correctly. Let me actually look at that. List dot count time complexity Python. Yeah, so it's O of n for a list with n elements, or string in this case. So this, the top, oh man, this actually kind of frustrates me. The top answer with a ton of best practices upvotes is an O of n squared solution when it really should be an O of n problem or an O of n solution. Yeah, so some of these are, no, this does not count, is killing me. Oh, I'm gonna have a stroke. Oh, okay. Am I missing something, Krispy Kreme or Ionic Fox? Like, I am I missing something? Because there's so many of these like highly rated solutions that, I mean, maybe this. I guess it's possible that some of these lower Q, or I guess higher Q problems, they don't really force time optimization, so people that are coming up with these solutions aren't forced to think about it. Pretty syntax equals better. But you can have pretty syntax without doing this dot count, right? I don't think my syntax was bad. I guess, yeah, here they're trying to flex that dot lower, or and doing all, well, sorry, they're trying to flex this like one line list comprehension, um, which, in my opinion, makes it actually messier, right? I mean, if you one aren't familiar with Python, or like just come in looking at this code, there's a lot for you to sort of like dissect in this one line. But I feel like my answer was more lines, but more readable. Yeah, I think the one light shit is, and by doing this, they've made it an O of n squared solution. The absolute madness. Maybe this will be more content that I do for like my YouTube channel when I make like standalone videos. It's just like doing a code roast or something. I'm just like roasting all of these top rated solutions. Like, I don't want to be like mean or anything, but people should know that this is not a good solution. Python's slow enough as is. We don't need to make it slower by taking problems that have O of n time complexity solutions and making them O of n squared. My Mandelbrot program? Yeah, that Python is slow for sure. Um, you know, So if I remember correctly, your Mandelbrot program you took and made faster by making use of data shaders, right? Which are like uh they're like they're bits of code that are bound to the GPU instead of the CPU, right? Um, so I wonder if because there's a way to actually do uh CUDA, which is like NVIDIA's sort of syntax for um, making code that will run on the GPU instead of the CPU. And there's actually a CUDA version of NumPy called QPy, which I've wanted to take a look at. It's possible you might be able to speed it up in Python, taking advantage of that ability. Um, right, the compute shader. Oh, what did I call it? Data shader. That's something else. That's a visualization library. Yeah, that's really cool. Getting to explore the fractal in real time. So could you like click at a point in like the initial fractal, and then it would like zoom into that point, and then click on another point, and it would zoom in to that other point? Because that'd be cool, man. It's like infinite universes of just. I love fractals. It's so cool. Um, Okay, a couple more problems, I think, and then I'm gonna call it. Apparently, the stream says I've been going for an hour and 20. Yeah, Christy Cream, we should go over to Ionic Fox's sometime, and he has some cool projects that he's done. He also has virtual reality headset, so dude, you should totally do the virtual reality Mandelbrot set. That would be so trippy. If you could like get that loaded onto your yeah, make it 3D somehow. I don't know really what you would do, but yeah, I don't know. I think there's something cool that could be done there. Um, what was I gonna do? More problems. Return negative. Oh, this should be easy. If true, return -1. How do I? A simple assignment, you were given a number and have to make it negative, but maybe the negative number is already negative. Oh no. The number can be negative already, in which case no changes. Why? 0 is not checked for any specific sign. Negative zeros make no mathematical sense. Okay, sure. So yeah, this is definitely an 8Q problem. If number greater than 0, number equals negative number, return number. Just gonna go straight to attempt. Boom. Okay, yeah, that I might start filtering 8Q and 7Q. It require like no thought for me. 6Q sometimes does, so as you can tell from like the first 6Q problem I did earlier with the parity. But that might keep content more interesting, I guess. Turn abs num times -1. Yeah, that could be one liner. Yeah, no, actually, I wanna. Oh, well, yeah, that's the very first one. So no if statement. Um, sure. Yeah, that definitely works. Oh my god. Oh my god. The absolute mad lad. The best of practices. Woo! All right, this guy is just trolling us. Oh my god. How high? This dude didn't type this out. This guy wrote a script to write this script and then submitted it. Amazing. Amazing. Woohoo! Yeah, no, I'm voting that for best practices. If I ever get there, my god. What was the maximum number? Okay, let's. Woo. I hate this. I'm mad now. Oh, okay, I can see the thing. I can. This is madness. Ah, that's okay. I'll give it clever. I don't want to give it best practices, but I will give that clever because they definitely. Ooh, now I want to write that program. I want to write the program that writes the program. That I mean that's not that difficult. That's just an iterator and then with the correct print statements and line inserts. I love it. I love it. Oh. All right. Well, I'm getting banned, guys. Sorry. It's been nice knowing you. I did not vet the content before streaming. What an efficient, imperfect solution. I will make sure to implement this strategy in my future code. Oh my god, I'm taking a screenshot of that and then uploading it to the Programmer Humor subreddit. This made my day. Assuming I'm able to. Paint and save that guy. I love it. Meanwhile, I'm like complaining about the time complexity of these problems where time complexity doesn't even matter. And this mad lad. You know, if the time complexity of the if statement is. But no, because, yeah, no, that there's no way. I mean, I don't know. It'd be interesting to benchmark that against, like, the normal solution. That's so funny. All right, one more problem, I think. Oh, X's and O's. Check to see if a string has the same amount of X's and O's. This method must return a Boolean and be case sensitive. The string can contain any character and be case insensitive. Okay. All right. This is a X's O's. This is definitely going to be one that oh yeah, this is straightforward. You just iterate over the string for C and S if well I if C dot lower X. Oh, I can just do X count here. Number of X, number of O, no. And then an X plus equals 1. Else elif C dot low equals O and O plus equals 1. Yeah. Then NO return NO equals X. Yeah, that. I think next stream I'm gonna filter and not do any like 7 or 8 Q. Because 7, 8 Q, those are like you don't quite know the language and you're trying to practice the language. You're not having to think about problem solving necessary. I mean, to an extent, but it's like once you know about if statements and for loops, you can solve this problem. So I might, since I already know Python, I might just do 6Q and above. Eventually I'd like to get to like doing 4Q and 3Q and up and just like keep going up as high as I can go. But when I was like practicing a few months ago, the 2Qs had some tough ones. It definitely would be like 1 per session if I were to do like a 2Q, at least with my current level of programming. So I think I'm going to avoid doing those for now. Return s dot lower dot count of x equals s dot lower. Sure, yeah, no, that's a perfectly valid solution. I'd say if we really wanted to care about time complexity, which for this type of problem, like who cares? Um, uh, Technically the dot count and the dot o would be two separate iterations over the loop. Well, yeah, I care. Because it's like a simpler problem, so I'm gonna try to optimize it since that's really the only challenge there is. Um, but anyway, thanks for hanging out with me while I code. I think that's it for now. Um, I might start recording some videos where I go over some of my solutions potentially and talk about some of the concepts in it. Like I know I've used like dot lower before. Maybe people don't know what that is, or some other stuff. I mentioned time complexity a lot, so maybe I make a video on time complexity and just like sort of how do you determine what the time complexity is for a given algorithm. But all right, thanks guys. Have a good one.